our next video is going to be about deductive reasoning. This is probably new to you to the term-wise, but again, it goes down to things that should be very similar to some of the things that you guys have heard before. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. Alright, so using this reasoning and properties to show expressions are equivalent. If it happens all the time, then it is obviously going to happen again, right? If a kid is constantly making a C in a math class, deductive reasoning is going to tell me that he's going to make a C in his next math class. Because I witnessed it. I witnessed him making a C in my math classes before. So obviously if he's in here again, he's going to make a C again. Okay? Same thing when it comes to, Mr. Marshall, Mrs. Wilson, and Dr. Barnes coming into classes. When they say, hey look, I'm observing this same pattern over and over and over again. So obviously the next time I come in, I'm going to see it again. Deductive reasoning, okay? So notice this from given facts to a conclusion. So I have to have proof of this. All right, facts is proof. I have to have something. I have to have done something to show me that this indeed is correct. And we use that when we were doing earlier things like the properties and all that. Those properties are deductive reasoning. Somewhere along the line, somebody has said, hey, every single time I do this, I get the exact same answer. So why not make this a rule? That's where these rules come from deductive reasoning. Is some mathematician came along and said, hey, look, every single time I do this, I get the exact same conclusion. Okay? Counterexample. An example that shows the statement is false. Again, thinking about counter, you are contradicting somebody. Counterexample is something that makes a statement false. Now, you don't need 1,000 statements to make a statement false. You just need one. You need only one counterexample to prove that a statement is false. That is a biggie, guys. Okay? I only need one thing, one shred of evidence to prove that this guy is guilty or that this guy is innocent. All right? It doesn't matter. I just need one shred of evidence that proves that what you're saying is incorrect. To put reason of doubt in my mind, right? So when I look at this, an example that shows a statement is false is a counterexample. And you only need one of those to make a statement false. Use deductive reasoning to tell whether each statement is true or false. If false, give a counterexample. All right. So this is dealing with subtraction. I don't really like subtraction. I really don't. I like addition. So could I change this to addition? Yeah, I could. I could say, hey, this is using the subtraction rule. Keep, change, change, keep, change, change. And then over here, do the exact same thing. So really I have P plus negative Q plus negative R, or the opposite of, is how you can read it as well. So this is P plus the opposite of R plus the opposite of Q. All right, so using deductive reasoning. Is this a true statement? Why is it a true statement? This is a true statement. And it's a true statement because all I really did was flip my opposite of Q and opposite of R, or negative Q and negative R, around. That's all I did. It says, use deductive reasoning to tell whether each statement is true or false. If false, give a counterexample. Well, this isn't false. So am I done? Yeah. But what property, again, if you write this down, I'll give you extra credit. So if you could tell me what property makes your statements true, I will give you extra credit. So what property makes a statement true? Well, I just changed the order, didn't I? So it's the commutative property of addition that makes the statement true. A little bit harder to see when it comes to subtraction. That's why I always change my subtraction to addition. Okay, what about this? Well, what's m divided by m? 1. So we get 1 times n. What's n divided by n? 1 times m. Well, n equals m, right? Is that true or false? That's false. That is a false statement. False statement. And again, if you were to like put this in like a couple sentences saying, hey, m divided by m is 1, n divided by n is 1, and then 1 times the identity property of multiplication tells me that 1 times n is n, 1 times m is m. So that's going to give me false statements. If you can somehow write that out in like a paragraph or even a couple sentences, I'll give you extra credit. But you also have to tell me what a counterexample of this is. And an easy way of doing that is saying, hey, look, if I say n equals 3 and m equals 4, then, hey, is that true? No. So 3 does not equal 4. Now, some of you guys are going to say, this is our counter example. Some of you guys are going to say, well, I can say that n is 3 and m is 3. No, because variables with different variables represent different quantities. Okay, so different variables represent different quantities. I cannot have the same variable, or I cannot have different variables representing the same quantity. So this is not possible. Okay, they have to be different quantities. Okay, so reasoning. A recipe for brownies is call for mixing 1 cup of sugar with 2 cups of flour and 4 ounces of chocolate. 4 ounces is a half a cup. So this is really saying, hey, I'm doing a half a cup of chocolate. They are all to be mixed in a bowl before baking. Will the brownies, will the brownies taste different if you add the ingredients in different orders? Relate your answers to the property of real numbers. It is not asking you to solve this. It is not asking you to do any math whatsoever except using your knowledge of your properties. So if I'm looking at this, I have 1 cup of sugar, 2 cups of flour, and a half a cup of chocolate, or 4 ounces, however you want to say it. Will the brownies taste different if you add the ingredients in different order? No. Why? Because of what property gives you that right. If I'm mixing something together, I am adding it. So what property gives you the right to say, hey, these are going to be the exact same thing? Good. The addition property. The addition property of addition tells you that they are going to be the exact same thing. So I would expect to see a couple sentences on this. And again, guys, If I can tell that it's an incomplete sentences, you have issues. So do not write out, sentences that are incomplete. You have in Mrs. Lawless's class, you're either in it or you're in another, maybe assisted studies or something. Have them look over it, make sure it's complete sentences. Do not just, give me incomplete sentences on this. Do not do that. So I can say the brownies will not taste differently if I add the ingredients together. Let's see here. The brownies will taste the same no matter how I add the ingredients because of the property of the commutative property of addition. So the brownies will taste the same no matter how I add the ingredients. Because of the commutative property of addition. Sure, spell that right. Yeah. That's all I'm looking for on this. Okay, the brownies will taste the same no matter how I add the ingredients because of the commutative property of addition. Bam, I answered the question. Alright, that concludes your guys' lesson in Chapter 1, Lesson 4.